I have got this function being drawn, and they said that x is greater than 4. We sketched the graph, which I have placed it on your notes. They mentioned also, can you indicate the position in relation to the origin? This largely means that you should draw to scale in relation to the origin. Meaning, if my x is 4 onwards is at this position, this is my 4, 1. The 1 should look smaller than the x values of 4. Okay, this is the graph here. They don't need you to state, but can we just state the range first? It will help us in a while. What's the range of my current function? Range is always from the lowest to the highest value. So in this situation, the range is 1 to infinity. Okay, lowest at 1, highest at infinity. Okay, then comes this problem where we need to understand that there's two parts to it. Number one is, can we show that the inverse function exists? What do we do when you want to show an inverse exists? We mentioned on the previous page, to show inverse exists, we show f is 1, 1. So is this a 1, 1 function? You ask yourself, if you draw any horizontal line, does it cut twice? Okay, it doesn't. So we can say for any horizontal line, y is a, with a larger than 1. So what am I stating here? This is the range of f. Okay, I'm only mentioning the values that are larger than 1 because that is my range. And it cuts the graph at only 1 point. Okay, right in a sequential way, you have to first mention that therefore this is 1, 1. And because it is 1, 1, so number 2, the inverse will exist. Okay, we write systematically. Cuts 1 point is 1, 1, f inverse exists. So there's a second part, or the last part of this problem. We would like to find f inverse in similar form. So this is number 2 that you need to solve. So I haven't shown you how we do something like that. I will explain it over here. Remember that, okay, so I'm going to write on the bottom right. For any function f, usually we say y equals to fx. So if you want the inverse function, what will happen? You visualize as this f will be moved towards the left. So if we move it towards the left, it becomes f inverse. So we write as f inverse y is x. And more crucially, the difference between fx and f inverse is who is the subject. For a f function, you have y being the subject of the equation. For the inverse function, it is actually x being the subject of the equation. So we change that and make x the subject. Therefore, when I start the problem, we should say we let y be equals to fx. And we fit in the equation. Your goal is to make x the subject. There are two ways to proceed. The first way is you can do complete the square. So to make x the subject, because there's x squared and x is confusing, we will complete the square. Okay, so let me write here, I am doing, there are two ways. One is complete the square, or B, we could apply also quadratic formula. Quadratic formula is the one that's slightly more confusing. You have to apply your negative b plus minus. Okay, this is the quadratic formula that I'm referring to in order to make x the subject. Okay, usually I will go for completing the square, but up to you, both are fine. Okay, so let's finish up. We are trying to make x the subject, so can we simplify our equation? let me have the x values to be on the left. There will be a square root when we want to make x the subject, and we can eventually shift the 4 over. So there will be a plus root or there will be a minus root. How do we decide the sign of the square root? Okay, so I put a star here. To decide whether you want to select the plus or the minus root, you check against domain. Because you are looking at x, x refers to the domain of the initial function. X values are domain. So what's the domain? The domain is x larger than 4. Okay, that's what the question gave initially. This is domain x larger than 4. So which of these two values will give you x larger than 4? It must be the plus root. If you have 4 minus something, it will be smaller than 4. So you can say that we reject this. And the reason is because x is supposed to be larger than 4. So what is x? Again, we made x the subject. Remember what we have here? X subject, so that x is f inverse y. So this is actually my f inverse y. So we say f inverse y is therefore your 4 plus square root y minus 1. The conventional way to represent a function is always as x. So at the last stage, because we still have y, we just make an alphabet change to write everything in terms of x. Because all functions we will present as x. Okay, that's the only reason why we will make this change. Okay, I am changing all the y to x because the conventional default notation is for x for the function. Okay, and one last stage. If we look closely at the question, they said in a similar form. Similar form means what? You have to look at the equation they gave. This is a mapping notation. You have to use the same notation and you must state the domain because every function comes with an equation, a rule, and the domain. So you have to state back that same notation. Put here first. So mapping notation and domain, you have to write both. So I come back below, we use that notation in similar form. So you say f inverse. Okay, this may be the first time you're writing it. So let's follow closely. You put colon and you write x. The arrow is with a vertical line first before an arrow for the map. Okay, not just an arrow, vertical line and then arrow towards the right. And you just change the equation that you have into this. So this is mapping notation. But we need to state the domain of f inverse on the right hand side. So this is where we apply the property on that previous page. If I want to write domain of f inverse, what is this equals to? This is equals to the range of f. Use the property that we talked about on the previous page. If I want to find domain f inverse, this is range f. So what's range f again? Range f is 1 infinity from the graph. Okay, so we fill in here 1 to infinity. Okay, but because they ask for similar form, this is one way to write the domain. The other way to write the domain is now to represent it as x values. What is the values here? It's 1 to infinity. So you can also say x larger than 1. Okay, but it will be now x because my equation is all in terms of x. When we state that new domain, it's based on this domain that we have, we change it to inequality, so x larger than 1.